The intersection of endurance sport, health, fitness, and life. Challenging conventional ideas and empowering people with the science of self-propelled motion. This is the Endurance Experience Podcast, hosted by Tony Rich.
Big data and cloud technology has enhanced our capabilities to accumulate and analyze data, leading to data-driven decision-making by utilizing pattern recognition algorithms to detect behavior. And it's behavior that we may be completely unaware of, revealing unconscious thought processes that drive us. And big data is just one of the doors that has led us to this new age of wearable technology, which has grown rapidly, giving people the ability to empower themselves and potentially take control over their fitness and health. And that's what we're going to talk about today. Endurance athletes were some of the first to get into and popularize this space. You'll hear in the podcast I talk about being one of the early adopters in the early 2000s to an early form of wearable tech for athletes called the Timex Body Link system. You can Google that and see how unbelievably, in hindsight, crude that looks compared to the wearable tech of today. I think it was sometime after the mid-2000s where wearable technology became mainstream. Fitness trackers and watches that accumulate biometric data and provide output in these robust data visualizations in smartphone apps. These are what gave people a unique line of sight into what's happening with their health and give them potentially actionable steps with everything from their sleep, their activity, their nutrition. So just some examples of some of the wearable technology that's out right now. I recently had a couple of athletes of mine test out a new form of wearable technology from a company called TimeWear. They develop a garment, a shirt with sensors in the shirt that analyze breathing and derive threshold levels, right? When you're working out and you're training, and it connects to the app, and it will give you threshold and aerobic and anaerobic threshold levels. That's pretty innovative. Now there's also smart rings, which are becoming more popular, that accumulate biometric data. Not to mention do things like open your car door and swipe for payment in stores. And it's not just fitness trackers. There's the IT bra, which is a wearable technology that claims to be able to detect breast cancer more accurately than a mammogram. There's the Owlet Band, which sort of looks like a form-fitting championship belt that's worn around the mother's stomach and midsection. And that is supposed to track a number of fetal vital signs and fetal wellness. There's been at least one attempt that I know of to develop smart contact lenses. There's one company related to Google that was trying to develop a glucose sensor. I think that since has been put on hold. But that's where the wearable technology industry is going. I mean, are we just a short putt away from not wearable technology, but implantable technology? As you'll hear from my next guest, we may already be on this horizon. Dr. Lauren Costantini has a PhD in neuroscience, and she's a subject matter expert in wearable technology. She's led startups, and she's been instrumental in helping to bring about an innovative product for women, which she talks about in the podcast. She's a frequent lecturer on the topic. She's been on C-SPAN. She's even got a TED Talk on wearable technology that is very popular. I'll put the link to that in the show notes for everyone to take a look at. Dr. Costantini is also a former professional mountain biker and cyclocross racer. And she also spends her time as a youth sports coach. I have a conversation with Dr. Costantini about the evolution and current state of wearable technology. I get her opinion on how the landscape may change, and also the evidence that it will continue to help athletes and the general population self-execute, change behavior, and even make better health decisions. So, without further delay, I give you Dr. Lauren Costantini. I am on with Dr. Lauren Costantini. Thanks for coming on to the podcast.
Thanks for having me.
All right, this is our podcast on wearable technology, and I've been wanting to do this podcast for some time, and I know I wanted to do it with you. I know I had to get you on the podcast. Your TED Talk on wearable technology is one of the best TED Talks that I've seen, and I think it was voted one of the 10 best wearable technology podcasts. Is that right?
I think it was, yeah. I'm thrilled and surprised and excited that people have been inspired by it. So thanks for mentioning that.
Yeah, and you were on that podcast, on that list with Steve Jobs.
Right. I saw that. I couldn't believe that when I saw it.
Hey, you that's always a conversation starter for you.
That's right. That's my 15 minutes of fame. I'll put that on my resume.
And you were also I might add, the only woman on that podcast.
Right.
And you know, we have underrepresented and underrepresented participation of women in STEM fields. And I think someone like you is a giant in the industry that can help us get more female representation into science, technology, engineering, and math. Are you often tapped to speak with women about that topic?
Yeah, I'm doing a little bit of that, and I'm volunteering with a lot of the organizations, both locally here and nationally, to work on some research identifying what it is about girls that they sort of lose their confidence when they're young. And so it's been pretty fun. But yeah, always trying to help girls with their confidence, both at the STEM level and also in athletics,
right.
Mountain bike. So I coach girls on the mountain bike too, and that gets them empowered and confident in all aspects of the life. So yeah, it's been fun.
I see. Impressive. Well, for our listeners that don't know about you, in your own words, so I understand you have a PhD in neuroscience and biomedical science. How did you get into that yourself, and how did you decide to make wearable technology something that you wanted to dive into?
Yeah. Well, I've had a really circuitous path over my life in general. I actually give a talk on just that fact, that you don't have to have a defined career path in order to have a fulfilling life. So I started life as a dancer, and I started at the age of 3 and was very serious by the time I was 12, doing TV commercials and traveling around the country and competing, and my goal was to dance on Broadway. So I even started undergraduate college as a dance major.
Wow.
And, and I always was interested in science and biology, but dancing was my life. And so I started as a dance major, and for about a year and a half while I was in college, I was going down to New York City and auditioning on Broadway. And they kept saying, "You're a good dancer and you're a great singer, but you're too short." So I'm a towering 5'1". I'm pretty small. And so I kept hearing that over and over. And although I'm pretty stubborn, height is not something that I have complete control over. So after a year and a half of that, I decided to switch my major to biology, and ran into a professor there who was a neuroscientist, and took his class and was just completely enthralled by the brain and how we think we have it figured out at some point, either with the disease state or with a healthy state, and then it changes on us because we still have no idea really how the brain works, both at a micro and a macro level. We've got the basics, but it's surprising us. So that's when I ended up going from dancing to neuroscience. I mean, it's an obvious path change, right?
Wow. That's impressive. Well, if you ever get bored with neuroscience and wearable tech, you can also just, switch gears a little bit and go into some dancing on Broadway.
Right. That's my backup plan now. So yeah, I just love neuroscience. I got my PhD and went to did a postdoc and stayed in academia for a few years. I was on faculty at Harvard Medical School for a few years and had a lab that was really focusing on Parkinson's and Alzheimer's disease, so neurodegenerative diseases. And we were working on different types of treatments. We weren't doing the basic research of how those diseases are caused or progression, but we were focused on testing out different treatments. Right. And so then I really got interested in the pharmaceutical and treatment side from a career path. So I left academia and moved to San Francisco and started working in the biotech space in Silicon Valley for 7 years, and really loved that because in academia you can do great research, but I really wanted my discoveries to get to the patients. And in academia they go to the journals and people read the journal articles, but I wanted to see my research get into clinical trials and go through the FDA and get into the actual hands of the patients. And so that's what happens in the biotech space. You actually make discoveries and then quickly move them into clinical trials, and you can actually see your work having benefit with these patients. So I stayed there for about 7 years, and then I was in Silicon Valley during the dot-com boom and bust in 2008. And so all the biotech companies were a little bit in shambles during that time. Ours did survive, but I did decide to leave Silicon Valley for a couple of years and live elsewhere, and planned on coming right back to San Francisco. And so where did I want to live? And at that time, I had been an athlete for many years. I switched from dancing to running and then to cycling. And so when I was in San Francisco, I was doing a lot of bike racing. And I decided that Boulder, Colorado was a place that I'd love to go and live for a couple years because it's kind of known as the mecca of outdoor sports.
Yep. Yep.
So I came to Boulder and worked. I actually did find a job at an Alzheimer's disease company, a startup company, and really fell right into the athletic world in Boulder and absolutely loved it, and planned at that time to be here for 2 years and now it's been 12. So I'm
Wow.
not sure what happened.
Yeah. Yeah, athletes that go out to Boulder and just don't come back. So
Exactly
talk
right.
about that. What type of cycling, for our listeners who are curious, what type of cycling do you do?
Yeah, so I started as a mountain biker. I actually just bought like a Walmart mountain bike to get around town when I was in grad school because I couldn't really afford a car. And then a friend of mine got me into mountain bike racing, and I really loved being on the mountain bike and didn't even buy a road bike for many, many years. And so I was able to represent the U.S. at the Masters World Championships. This was, 2000, well, I won't say, a long time ago. And ended up with a bronze medal, so I was excited about that. And then I switched to cyclocross. I don't know if your listeners are aware of cyclocross, but it's kind of like the steeplechase of cycling. You're only racing for about 45 minutes to an hour, and you're jumping off and on the bike, running over barriers, running up hills, putting your bike on the back, and dropping it down and jumping back on. It was really fun. So then I raced that for about 12 years and moved up the ranks to the pro level and sprinkled some road riding and trail running in. So that was kind of my main racing career back then. But I was somewhat sponsored, and I had pro written on my license, but I always had a full-time day job. So I would line up with women who, that's all they did was race bikes, and they had to win that race or else they wouldn't be able to pay for their rent. And I never really wanted to be in that position. So I kept my neuroscience jobs while I was racing. And now, like I said, I just focus on getting others into the sport. I love coaching kids here in Colorado and Wyoming. I did leave one of my companies to start a mountain bike tour guide company, so I'm doing that as well on the side. And occasionally I do a mountain bike stage race now. But my racing career is kind of twilighting, except for the stage races, which are really fun. They're kind of 5 or 7 days of mountain bike racing, and it's more like a little vacation than anything.
Wow. PhD, dancing, racing, bronze medal. My goodness, if we ever need a specimen for cloning, I'm going to offer you up.
You're too kind. Actually, on paper, it looks like I just can't hold a job. So,
What bike are you? Road bike are you riding nowadays? Just curious. What brand?
oh, it's a little frame building company here in Boulder called Mosaic. So it's probably not one that too many of your listeners know. But one of my mountain bikes is a Specialized, which I love, but yeah, my road bike is a Mosaic. It's beautiful. I love it.
Right. Interesting. Wow. Amazing. Well, let's jump into wearable technology. So for our listeners, the people that listen to this podcast are endurance enthusiasts, cyclists, runners, triathletes, and I guarantee you probably north of two-thirds of them have some form of wearable tech. But for someone who may not be familiar, for someone who's holding out, if you can take us through the evolution and practical uses of wearable technology and where we are now.
Yeah. Well, it's interesting. I'm sure a lot of your listeners have heart rate monitors and different types of sensors like that. But really, the first wave of wearables was decades ago with hearing aids, because we were using miniature microphones and medical devices with bipotential electrodes and temperature sensors. That was way back when. The second wave then was more 2006 to 2013, where I think your listeners are more entrenched, and that's taking technologies from other spaces and making them more wearable. So we've always had accelerometers for aerospace and other industries, but now we're putting accelerometers into a Fitbit so that we can count our steps and look at our actions. And so that was starting to happen in the second wave. Also, of course, the smartphone interface started happening with microphones and cameras. And then, by 2014, it was dubbed the year of wearable technology, and activity trackers grew in popularity, and then the Apple Watch was introduced.
Mm-hmm.
The third wave is kind of happening now, and it's more wearable-specific technology. So now we're designing sensors to be wearable versus taking technologies and trying to fit them into a wearable. So we're making things smaller and more flexible and more comfortable and have low power demands and making them more energy efficient to be specifically made for wearables. And some are integrated now into textiles and shoes so that it's easier for the athlete to use. So it's been a pretty interesting evolution. Euromonitor cited that wearables are projected to exceed 305 million units by next year. And that's like a 55% annual growth rate. So even in the recent years, we're still seeing an explosion year on year of people becoming more interested in wearables. And that's, as you'll probably want to talk about later, healthcare and fitness and medical.
I remember when it was probably early 2000s, I was one of the early adopters to wearable technology. Timex had come out with this wearable tech called the Body Link system, and it was a watch, and it was the speed and distance came from this gigantic arm pad. I mean, it was probably the thickness of two men's wallets on your arm. And then they had one thing called a data recorder, which was another thing that you had to clip onto your belt. This was probably something somewhere around 2003. And then it had a heart rate strap. And I just remember from there, it just took off. Every year, it just got smaller and smaller. And then, other players started to come in. And then the arm pad just disappeared. And you no longer needed that. Everything was inside of the watch. And so the technology just got better and better and better every year. And this thing called Moore's Law, which, this says that the technology processing doubles every 2 years or something like that. But, I mean, the way that it took off was very surprising.
You were an early adopter for sure. And I didn't even realize Timex was involved in wearables back then.
Yeah.
So that's interesting.
Well, and then Garmin came in, and then Garmin, pretty much, kicked Timex out of out of the space. But so let's go through. So you were one of the, or you and your company was instrumental in a fertility monitor. Did I read that? What was that about?
Yeah. So the company is called PrimaTemp. It's still around. I'm still on the board of directors, but I was CEO for that company for 5 years. And we developed a wearable that tracks a woman's core body temperature. And it uses an algorithm to identify when she's most fertile. And when she's most fertile, it sends an alert to her smartphone. And to his smartphone, if she so chooses. You can see where that's going.
Right.
So, it's developed for women who are trying to get pregnant, and our goal is to give them other options if they are having trouble getting pregnant, so that they don't have to go to in vitro fertilization right away, because that's a long and expensive process. And so we think that a lot of the infertility that's out there is really just a timing issue. Women's cycles, the temperature cycles up and down, and some women have irregular cycles, and it's hard for them to identify when they're ovulating and when they're most fertile. So our tracker, it is an internal tracker. So it's actually inside the body. It's an intravaginal ring, just like a Nuva ring, which is a intravaginal ring that women have been wearing for many, many years. It's basically a contraception so that you don't have to remember to take the pill every morning. You just insert this ring, you wear it a month at a time, and it releases birth control, and at the end of the month you take it out, throw it away, and put another one in. So we took that exact form factor, And we took the medication out and we put a continuous temperature sensor in and a Bluetooth chip and a couple of other antennas and other batteries. And now we have a sensor that is truly core temperature. You can't get much more core than inside the body.
Right.
It's communicating with the smartphone and sending data to the phone. And then there's an algorithm that tracks her ovulatory cycle and sends an alert to her phone. So it was a really fun program to work on. Pretty challenging from the engineering standpoint, too, because it's the first wearable that is Bluetoothing from inside the body. Mm-hmm. Without any repeater kind of attached to it. So there's a lot of implantable medical devices that Bluetooth to something outside the body, but there's another device intermediary that helps that communication. So ours was simply just the ring inside the woman and her smartphone. So,
and this is something that would be utilized for either trying to get pregnant or trying to avoid getting pregnant.
You got it. That's true. We don't talk about that much, but a lot of people said, wait a minute, all you're telling me is when I'm most fertile, so we can avoid also. You're absolutely right.
Well, I'm a guy, so, I'm thinking about that. That'd be great. You send it to the guy. Now the guy knows.
Exactly.
Got it.
That's right.
Interesting. I'll have to look this one up.
Yeah.
Wow. So how's that doing? Because there's a couple of trackers out there, but I don't think they have implantables. They just you have to put in the information.
That's right. And we were trying to also make a product that the women didn't have to sit there on their phones all day inputting information. I took my temperature with a thermometer and here's what it is. And now I have to look at a graph and identify what's going on. We wanted it all turnkey so that she just has to wait for that alert to come. So, and there are other fertility trackers, one that is around the wrist that takes sort of a peripheral skin temperature, so it's not true core temperature. Mm-hmm. There's a couple others that are basically just ask you to take your temperature orally with a thermometer, and it inputs the information automatically. So there's no others that are insertable inside the body like ours. Yeah. And so easy for a woman to use. She could take it out anytime. It's very easy for her to use. So the product is doing great. We have not yet launched. We'll be launching probably in the next few months. We're just doing the final quality control on the manufacturing, which is looking great. And so, yeah, keep an eye out for it. The product's called PRIA, PRIYA. And it's been an interesting process being part of the hardware and the software side. So we can talk about that a little bit later also.
Yeah. I'll put the link to some information in the show notes. I could also see some potential application for training. I mean, yes. Exercise physiologist by the name of Stacy Sims recently wrote a book where she talks about the training, the 28-day cycle, and what female athletes and coaches should be looking at from a 28-day cycle perspective, follicular phase, luteal phase, what might be happening in the body that might lend itself to training and racing changes, or tactical things that you could do with nutrition during those phases, whether your core temperature is high, low, whether you're losing more sodium, things like that.
Right.
So I could see some potential application there.
Yeah, absolutely. And we often have researchers contacting us, asking us whether they could use our product to research some of these other applications. Mm-hmm. And I loved Stacy's book. I haven't read her book, but I've read a lot of her writings, and I'm so glad that she's addressing this because the woman's body changes a lot during that course of the cycle that will affect training, and not even at an elite level. Even sort of the weekend warrior women are feeling changes throughout the cycle. So I'm so happy to see that that's now coming into the forefront. The other request that we get a lot about, and I'd love to hear if you're familiar with any of the research on this, since you've got such a broad experience, is training to a core temperature. We've had a couple of investigators say, yeah, we trained to heart rate and we trained to wattage, but what about training to a certain core temperature, raising your core temperature and being able to maintain that core temperature throughout your training cycles, basically.
Yep.
So we haven't really started official collaborations with them yet, but we've had a lot of discussions with them, and that's something that we're very interested in looking at as well. Just melding the science of wearables with the athletics, which is what I love.
As soon as this technology is there and it's good and it's reliable, it can be used to draw logical conclusions from cause to effect about what you need to do from a nutrition standpoint. There's tons of possibilities there.
Right.
Yeah. So let's talk about the landscape here. So Garmin seems to be the wearable tech of choice for athletes. I go to run. I'm wearing 4 wearable tech Garmin devices. 4, right? So, and among the recreational folks, or just sort of general health and fitness folks, Apple seems to be the wearable tech of choice. So the question here is, where is it going? Do you think that there's going to be a handful of big players that are going to emerge from the wearable technology arms race? Is it going to be some form of consolidation or collaboration? What do you think?
Yeah. Well, there's a big long table of all the companies that are involved in wearables, and even as they become more advanced, introducing more sensors and better components to enhance the value proposition. Lessons of history tell us that hardware will always be prone to commoditization. So I do think that as this happens, the role of sensors only becomes more important. The hardware prices being constantly squeezed and increasing proportions of the value that companies can capture from products will really be from the data that the products can generate. The key hardware components is the sensors, and understanding the development is important, but expertise on the biofeedback, what is that really telling you? And Apple and Garmin seem to be sort of the hardware and some software guys, but I think it's important for others to be at the table at those companies, and I don't see it happening yet, to really expand into other aspects. So like you said, you go out running and you've got sensors on that are telling you probably your heart rate, maybe even wattage. But the future of where Garmin and Apple and these other companies need to go is not just overall improved performance, but we're now focusing, and athletes are demanding, how do you tell me how to prevent an injury? And how do you tell me how to improve my recovery? And so there are some very small companies that are out there that now have developed sensors for heart rate variability and other parameters that can calculate a readiness score each morning. So you wake up in the morning and your new sensors are looking at different aspects of your body, and they're saying, okay, you've got an 8 out of 10 readiness score today, so you can go and work out. Whereas these sensors are now also saying if you wake up and you've got a 4 out of 10, you really should take a day off. And so I think we need to go beyond what Garmin and Apple are doing right now and look at some of these other sensors that will give us different parameters. And one example that I really love, besides the heart rate variability, is sleep. Now, as much as sleep is actually kind of a trendy word right now, because we're talking about sleep hygiene and don't look at your computer or your phone for an hour before bed, and meditation, but it really does impact everything for the athlete: physical, nutrition and appetite, motivation and drive. I once heard an investigator saying, you have to think about sleep like breathing. So you never say, well, I didn't take enough breaths yesterday, so I'll make it up tomorrow. And that's how we treat sleep. Oh, I didn't get that much sleep last night, but I'll make it up tomorrow. The data are coming out now showing that when we have a couple of days of lack of sleep, there are some pretty chronic changes in the chronobiology of our bodies that are affecting day to day as well as athletes' bodies. So I think that the players in the field, whether it is the big ones like Garmin and Apple, or it's these new small companies that are looking beyond just heart rate and wattage and how fast can you go and how hard can you go, but it's these other more subtle changes that are really going to make a difference in the athletes' lives. And back on the sleep story, there's a study that showed one of the famous basketball players increased their sleep by only 2 hours a night, and their free throw scores increased significantly. So there's some really interesting studies out showing how something like sleep can really make a big difference in athletes' overall performance. So, and of course, Under Armour has been looking at different sensors on the body. So not just for the athletes, but in all these other sectors that wearables are really focusing on.
Yeah.
So hopefully Garmin and Apple will bring in the expertise to expand what sensors they have on their products. I mean, I ask you, what does your Garmin tell you, actually? Is it just something that's heart rate based, or what else is it telling you?
Yeah, so Garmin has this thing called Garmin Connect, where it's a lot of the data it's very siloed. So you go out and you do a workout. It has sleep. Yep. You got to do a workout. It will have ground contact time. It will have vertical oscillation, meaning how much you're going up and down, stride rate. It has power, and different things just like heart rate zones and cadence and right. Things like that. And swimming, it will do swim count, stroke count, and cycling, it will have power if you use a power meter. So a lot of the data is just it is very, very siloed. And you look at something like the Apple Health app, and you're thinking, how come these two? Well, I think they do talk to each other. They might send some information, but I think you're right in that a bigger picture type of analysis could be there. Fitbit just launched this Fitbit Premium, where they will do this sort of high level roll up, like you were just describing, and create a report that you can send to your doctor. So that's might be the next phase, where all of this data that is very siloed, somehow if we can get it all together to draw 50,000 foot conclusions about whether it be health, or whether it be training, undertrained, overtrained, things like that. It seems like there's opportunity there for some of that with all of these players out there.
Yes. Yep. And you're right. Having the Apple Watch and Apple Health connected to all of these things and integrating all that sensor data from the other third-party apps, I think would be so useful to not just athletes, but like you mentioned, also the doctors and wellness and healthcare. Definitely.
Yeah. So let's talk about that. How do you think the fitness business will be impacted? How do you think the healthcare, the medical field will be impacted? So one of the things that I've seen, and this is something that came about within the last, I say, 10 years or so, where I can now train and coach someone wherever they may exist. So it's location independent, and that's a direct result of big data, and everything that someone does is captured inside of the cloud with wearable technology, and using a software called Training Peaks, we can collect an athlete's data and see everything that they're doing in real time. And previously, if somebody wanted to hire a fitness professional, they would need to go to a personal trainer at their local gym, and they need to spend time to go to that personal trainer for an hour, and then They may put them through a workout for an hour, then they leave, and then come back in 2 days, and then put them through another workout. The wearable tech allows me to have more information about a human being, what they're doing in real time, and in such a way I can have a client wherever they may exist on the planet Earth, and then connect, just like you and I connecting right now for the podcast, peer-to-peer communications, whether it be Skype, Zoom, things like that. And it's opened the door for the multi-sport coach to have a fitness business. So that's from my side of it, what I see on the fitness business. But I can see similar things happening with just general healthcare.
Absolutely. I love that. I'd never really thought of exactly what you said, in that back in the day we had to go to the gym and sit with a personal trainer and work out with them, and they would take notes and then come up with a plan. And now you're seeing your clients' workouts in real time. Right. In the cloud. It's funny to think about how we used to do it back in the day, those of us of a certain age.
Yeah, exactly.
But you're absolutely right, and I love the way you describe that. And I think a lot of it also is not just having access to other athletes from a coaching and from a competitive standpoint, but it's also being more motivated. So Fitbit is a great example of just getting people motivated. Maybe not the athletes that are listening to your podcast or the elite athletes, but these are motivational products, which is great, absolutely great. Whereas Garmin is a little bit more, less on the motivational side and more on the athletic improvement side. Mm-hmm. So that's what I really love about where things are going on the fitness side. The other thing on fitness is, and I'll talk about healthcare in a sec, but is that using this data for the business of sports, recruiting and choosing athletes at all levels is now becoming a wearables-focused business. So when you've got, you go out to the field and you're looking for your next NFL star, and the coaches are sitting on the sidelines, those football players are out there training with sensors on them now, so that the coaches in the stands who are deciding who to recruit or who to draft are analyzing the data in real time. And so that's a positive and a negative, I think. I mean, all of these new technologies have positive and negative outcomes to them, but I think the coaches are really loving the fact that they can look at muscle contractions and speed and acceleration while they're looking at the players on the field, and it's going to affect how Olympic athletes are chosen, how pro-level athletes are chosen. So from a business perspective, I think that's really going to change a lot of that fitness business as well as pro sports. And then on the healthcare side, that's in the beginning of my TED Talk, I usually love to remember that I said your body is radiating data, and your body's been radiating data since the beginning of time. But this is really the first time in history that we've got sensors that can collect that data, and for us, the consumers, to look at it. So in years past, our body's been radiating data, and doctors are pretty much the only ones who have been able to gather those data and look at them and tell us what our bodies are doing. But this is the first time in history that we now can look at our own data and make decisions on our health and wellness without the need to go to the doctor's office. And it's everything from ECGs and EKGs. You can look at your heart health with AliveCore products. You can look at your mental health with some of these new sensors. You can look at your, like we were saying, the sleep. If you have a sleep disorder. Now, most of these things that we're familiar with at the consumer level can't really call themselves diagnostics, because then the FDA comes in and starts slapping people's hands. Right. if you are using an app that's checking your sleep, they could give you a red light saying you may want to go see someone because you may have some issues with sleep apnea or such a thing. So in the healthcare space, what I love about wearables, it's untethering us from the doctors. Right. And so I see a future where we're not going to go to the doctors to be diagnosed with things unless they're very serious or until we need surgery. So we will have, and I don't want to get into the tricorder of Star Trek, but although that would be great. But I see us having a lot more control over looking at our own body's data. Now, that being said, we need these sensors to be giving us information that's actionable. And so a lot of these wearables say, for instance, Fitbit, you took 10,000 steps today. And people look at their watch and they say, oh, 10,000 steps. But what's the actionable action that they can take with that? Is that a good thing? Is that a bad thing? If they have diabetes, should they be getting more? Should they be getting less? So the clinical relevance of some of these wearable sensors, I think, needs a little bit of improvement on telling the person, okay, what do you do now that we've collected this data and here's your number? And that's been improving steadily over the years, certainly. But in the healthcare space, it's a little less of an issue because you do have doctors sometimes assessing the data from these wearables and helping the patient understand what's going on. But from the consumer level, I'd love to see some of these wearables give a little bit more data on, or a little bit more information on what to do with that data.
Mm-hmm. Yeah, and so that would be the gold standard one day, to be able to have pattern recognition, where you would be able to have some device that will tell you in advance that you're going to get sick or you have some more serious problem. And,
yes.
So and Absolutely. Ideally, that might be the slope that this goes towards. So, but yeah, you had mentioned the evidence for whether or not the wearable technology right now changes behavior, right? So is it showing that it's impacting better decision making among people that are using the technology?
Yeah, there's a lot of studies out there in athletes that are showing great improvements in athletes' performance, but that's the motivated population. Mm-hmm. So when you start talking about the obese population who, they've been hearing for years from their doctors, get more exercise and eat right, we're not quite seeing the behavioral modification that we really want. And same with the diabetes space. So in healthcare, one of the big wearable promises years ago was diabetes, in that you've got them on a glucose pump or an insulin pump, so they can alter their administration of insulin based on their behaviors, and they also get feedback, a red light or a green light saying, great, you just had a kale salad. You don't need this insulin injection like you had yesterday. Or a feedback that says, you just had, pasta Alfredo, and now this is a red light, so now you're getting a pump, and you should really not do that tomorrow. Mm-hmm. That, unfortunately, is not showing sort of the modifications that we wanted in the populations that are not motivated. In the athlete populations, we're all super motivated, and we're seeing great behavioral modification there, except for the recovery, which I'd love to talk about too. We're not showing that athletes are taking the rest that they need now that we're showing that they probably need more rest than before. Yeah. But the behavioral modification in the less motivated populations, I think it's going to need a little bit more than just, here's the sensor data, here's what you should be doing to improve, because they've been hearing this from their doctors and their families for years anyway. So we need a little bit more of a trigger than that, and I'm not sure what that is.
Maybe it is nutrition. So we did a couple podcasts, one with Stefan Guinea and one with Daniel Lieberman. Both pointed to evolutionary mismatches. Basically, we we have this body that was designed by natural selection to move. We had to move for everything, to get food, to get where we wanted to go. Now, here we are, fast forward to today, where we're in a situation where you don't really have to move as much. You're sitting down, you're driving everywhere, and at the same time, the availability of food is at the highest. And as a result of that, the combination of those two mismatches results in the obesity epidemic and other health problems and such. One of the things that I realize is that it's very difficult to track food. MyFitnessPal has the tracker where you still either have to enter it manually or you can just take out your phone and scan a barcode. And the barcode scan became the next phase. We're in a situation where almost everything you eat has a barcode on it. And so if you can scan everything, take out your phone and scan everything, then it will suck the nutrients and the calories in, and then you can do, energy balance delta, energy balance, whether or not you're in an energy balance and such. Yeah. So that still, though, is a little hard to do on the nutrition front. I think if we were to come up with something that can derive caloric intake in a faster, more efficient way, then it could be in the face of people to show them, look, you're not in negative energy balance for the day or the week or the month. So there's some thoughts.
Absolutely. And I remember when it's kind of related in a less digital way, but when in New York City they started putting the calories of all the fast food restaurants up on the menu. And whether that did change behavior or not, or whether you just say, well, fast food people are still going to eat fast food, whether they know how many calories they are or not when they go into McDonald's. But I think they did actually show a change in behavior in those people. So I think there are so many groups, both academically and in industry, startup companies that are working on exactly that. What kind of sensor can we put on the body where it can tell how much food you're taking in? Is that going to be just a picture and a database, or is that going to be something on your body that's going to somehow detect food intake, the metabolism? Different people are going to metabolism food in different ways, and that's going to be pretty complex. But I think that's a gold mine that everyone's hoping for. Absolutely. Yeah. If you can look on your watch and see that you're in the negative or the positive, I think that would make a big difference in obesity and also in athletes. Yeah.
Excellent. So let's see. What's next? What do you see forthcoming next? Personalized medicine, women and child safety, maybe. What do you see coming there? By the way, before you answer that, do you watch Black Mirror?
Oh, I have. I haven't seen every episode, but tell me which
Black Mirror has a very interesting episode called Archangel. Check it out if you haven't seen it. But it's related to wearable technology. I just thought of it when about the women or child safety. But where do we see coming here? I mean, is it going to be cameras and audio equipment on children and people to ensure safety? What do you see here?
Yeah, I'm hoping it's not. There's also that Tom Hanks movie, The Circle, where there's cameras everywhere, and that's more like making sure you're a good person. But yeah, I'm hoping that we're not tracking people that way in the near future. But that could be. Well, when I first think about child safety and wearable sensors, I'm immediately thinking athletics again, because we're doing a lot of work in student athletes and kids on heat stroke and concussion. And heat stroke has become, I wouldn't call it an epidemic, but I mean, every other month you're reading about some child out on the soccer field that dies of heat stroke. Right. And so we're now starting to use temperature sensors on these young athletes to try to avoid that, because they just don't have the adaptive capacity at that age to alter their physiology when they are getting too hot.
Right.
And then concussions also. We now are developing, I was involved in a couple of companies that developed sensors that are inside the helmets and
Right.
can determine whether a concussion has occurred or not, or whether there are a certain number of hits. And the alarm will go off and say, well, that's 3 hits in the past hour. You should really, take this kid off the field. So when I initially think about child safety, I think about athletics.
Yeah.
But
NFL football helmets, that's a big issue right now. CTE and other issues.
absolutely.
Yeah.
Oh my goodness, the stories are coming out on a monthly basis now. But I do think for child safety in general, like you were saying, the cameras. I mean, we have a lot of tracking systems now with our iPhones, which is, the best we can do right now. But I can imagine that there could be, you don't really want to say you're going to chip your kid like you do your cat and dog. That in certain locations, you may want to do that. And that technology is absolutely there. We're doing, implantables for lots of different things. And one funny story is when I was out pitching my fertility intravaginal monitor to some investors, one of the guys in the audience said, "Hey, can you put a GPS on that so I can track where my..."
Oh, boy.
So that's a little bit extreme, but I do think personalized medicine is also it's already here.
Right.
We don't even have to call that coming next, because these sensors, the beauty of these sensors in the healthcare space is they're completely personalized. And so you're gathering data, like you said, with Training Peaks, you're looking at your individual athletes, and I bet if you lined up all your elite cyclist clients, you would still see lots of individualization, even though they're all elite athletes.
Mm-hmm.
That's how the medical space is already looking at some of these sensors. So we need to get the physicians on board to take the time to look at these sensors. They're already overworked with paperwork and electronic medical records. And so I think physicians in the general sense are not taking advantage of these sensors data just yet. But I think the ones that have become early adopters are seeing that, yeah, this is personalized medicine without all the hassle of personalized medicine,
Right.
which has supposedly been on the forefront for so many years. So I agree that that's actually happening now, definitely.
Yeah, and you mentioned recovery, and when you look at machine learning, you look at artificial intelligence and pattern recognition, I mean, there's the potential that this could turn into something that will be very helpful to athletes from a recovery perspective. I think right now, coaches like myself, we're looking at what's going to develop from this, because we may see in the future, in the very near future, that complete AI coaches will become a viable substitute for all athletes.
Oh, right? Really? Oh boy!
If you have good pattern recognition, where all the data, if the data is good enough,
right,
and all of the data coming in from different sources, and someone has a series of races on their schedule, the algorithm can say, look, I understand you got these 3 races coming up. Currently, you're undertrained or overtrained. Okay, let me prescribe this activity for you for the next 2-3 weeks. Mm-hmm. It's something that you can almost envision happening really soon if the pattern recognition gets better.
Yeah.
And
so Training Peaks will be on its own type of thing,
right?
And the coaches will no longer be needed.
Yeah, exactly. Yeah, it'd be complete AI coaches, and I'm sure people are looking at this now, and a complete robot. Certainly, a coach will maybe needed for less, more of the face-to-face interaction, explaining what it means and things like that, but. Certainly the possibility of being a viable substitute. I mean, you had mentioned recovery, and is that something that you can foresee as well? Just looking at the stream of data of someone's completed activity and getting better understanding of training stress.
Mm-hmm.
Yeah, and
absolutely. And I love that you're talking about overtraining. I was just reading several articles just yesterday about this, and that we're now trying to get sensors, and they're not out there yet with high resolution outputs, but we're measuring lactate and
mm-hmm.
chloride and glucose and pH. And those are the things, as you know, that really contribute to overtraining syndrome, or OTS.
Yeah.
So we're now starting to look at that, and boy, if you can get a picture of an athlete's lactate levels and chloride and glucose and pH, and you see things off the charts, that's usually going to be an indicator even before they start feeling the symptoms of overtraining. And I think that's going to be huge, as big as the sleep studies that are happening now. The only negative of that, though, is that these studies also showed that lots of money is going into these sensors that are sensing the physiologic changes that happen during overtraining. However, these very expensive studies also showed that the main predictor is more about the emotions and the depression and the lack of appetite, mm-hmm. and all the things that cannot really be identified by sensors. So one of the negatives of sensors is, well, actually, let me just do the flip side. One of the positives of sensors in athletics is that we can get emotional with our training. Mm-hmm. That's how overtraining happens. Well, if my coach wants me to do 20 hours of intervals this week, I'm going to go do 22 because that's got to be better.
Right.
So emotion does take over for a lot of the real motivated people, like the type A people, like probably you and I are.
Right.
But the overtraining parameters are going to be missed by those sensors. And so I think there'll always be a role for you, the human coach, mm-hmm. to talk to your client and say, okay, so I'm seeing this and that on your biology. They may show perfectly fine physiologic levels, but their performance is reduced. And then you have a call with them, and they say, oh, yeah, well, the 2-year-old kept me up all night. I got a promotion at work.
Right.
I'm really stressed by this. I had a stomach virus last week. I didn't mention that. So there's lots of things at that level that I don't think that these sensors are going to be completely autonomous for right. the athlete that really wants a full picture of how they're doing.
Yeah, I agree. And it fundamentally changes our role too. Like I said, it's less about getting someone in the gym and blowing a whistle at them and screaming at them, go, 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 this is all you got, right? And we become basically data scientists and project managers, right? And more so we need to have the understanding of exercise physiology, and all of us are going to need to become data scientists to be able to evaluate the output of everything and be able to explain it, draw conclusions from it, figure out when it might be right, figure out when it might be wrong, and then offer that support. So that's how the landscape might change.
You're going to become a little bit of a therapist in the future.
Yeah. Yep. Exactly. So let's see. How could all of this go wrong? What's the potential downside? Are there any perils? I think you maybe have touched on some.
Yeah. From the fitness standpoint, I think some of these sensors are making claims that are not quite where they are. And mm-hmm. I remember years ago when Fitbit was one of the only fitness products out there besides the polar heart rate monitors, etc. There was a big article in the New York Times by these elite athletes complaining that they were training based on Fitbit and the data were not as high resolution as Fitbit made them out to be. And some of these athletes got injured or were undertrained or overtrained. So I think some of these companies need to be a little bit more honest about what they're really able to share with the consumer. And at the clinical level, obviously the FDA takes a role in that. But like we talked about before, clinically relevant, actionable data from healthcare perspective. But I think the big elephant in the room, like you said, we're now collecting all this data from our bodies. Privacy is going to be an issue. Mm-hmm. Now, clearly we're learning just in tech in general that we really may need to read all that fine print when we check off the box that we agree to these terms of our products. But, when it comes to these very physiologic and health associated data, you think about, well, are the insurance companies getting their hands on this at any point?
Right.
And what if there was a breach in the cryptology of the data? And so I think there are people not only thinking about that at Facebook, but people are thinking about that. I think about that certainly at the health level. I've got all these sensors and they're really giving quite a detailed overview of my wellness and where are those data going and how can they be hacked in some way. So I think as the encryption of these data remain in the forefront, there's going to be a hack at some point that makes everyone stop and think. But I think that's something that all these companies need to be aware of.
Yeah, watch Black Mirror.
Okay.
Archangel.
Yeah. Archangel. I'm writing it down right now.
Actually, the entire series is about some form of wearable technology or technology, the good parts, and then when it runs amok. But particularly this Archangel episode, you're going to find very, very interesting. Okay. All right. Let's see. Anything else that you want to tell our listeners about anything that you're doing now? Anything you're doing with female entrepreneurship or some?
Oh, well, I love just, talking about entrepreneurship and helping people with a great idea, bring it to light in a business plan and how to bring a technology to a full story and basically I talk a lot with engineers. I mean, obviously I have a science degree, so I'm around scientists and engineers a lot, and they often have great technology ideas, and I like to be able to help them make a story out of it, make it easy to understand, and start telling their story out into the world so that they can move these products forward. There's so many great technologies that are in development right now, so I'm excited for all of them. Yeah,
excellent. I can't wait to see what the next few years brings. Like I said, I mean, I remember back in the early 2000s when I just started the early adopting, and then now to see where we've gone. And I think, okay, where are we going to be, 10 years from now? So, wow. Right. All right. So where can people reach you on social media or anywhere? Some of the things that you have.
Probably LinkedIn might be best. I do have social media accounts for a couple of my businesses and my personal, so I'm certainly on Facebook and Instagram, but I'm on LinkedIn as well and Twitter. So it's just Lauren Costantini in most of those channels. And I love hearing from people with questions or ideas or just general entrepreneurship discussions and brainstorming. So anytime, would love to hear from your listeners.
Awesome. And I will put information about Lauren in the show notes, her TED Talk, which you will all find interesting. And we're going to keep looking and seeing how well she's doing on the competitive cycling circuit as well.
Thank you.
All right. Thanks again, Lauren, for being on the podcast.
Great. Thank you. It was fantastic.
My listeners are fully aware now of my Black Mirror obsession. Definitely check out that series, Netflix, if you're at all curious about future and the potential for wearable/implantable technology. Thanks to my guest today, Dr. Lauren Costantini. That was a great discussion. You can definitely look her up on social media. And if you're out in Boulder and you want to do some mountain biking, check out her mountain bike touring company. I'll put the link in the show notes. It's called SacredRides. And thanks for tuning in. If you're interested in having a discussion about podcasts, you can go to our Facebook group, Endurance Enthusiasts. That's facebook.com/groups/Endurance Enthusiasts, one word. Thanks again. This is the Endurance Experience.
Follow Event Horizon Endurance Sport on Facebook, Instagram and Twitter for training programs and services. To become a member of our Endurance Institute or for a complete archive of podcasts, log on to our website, eventhorizon.tv.